Okay, let's continue with the next example. So again, we have this common kind of setup here with these equations, involving radicals and involving rational expressions. Is you kind of convert it into a you convert it into a equation we already know how to solve, and then you check your answer and see if they still work in the original equation. Okay, so continuing here, the next example is solve solve the square root of 2x plus 1 plus 1, so this plus 1 is outside of the square root, equals x. Okay, so we want to get so in the last example we had the radical isolated or on its side by itself. So that's actually the first thing we need to do, is we need to subtract 1 or anything that's outside of the radical onto the other side. So here now we have square root of 2x plus 1 is equal to x minus 1. Okay, so now in the next step is the same as the last example. We have to get rid of this radical here. So we're going to do that by squaring both sides. So we have the square root of 2x plus 1 squared, and then x minus 1 squared. Okay, so remember this this term here you have to FOIL out. You can't just, this is not x squared minus 1 squared, right? So this one simplifies because the square root and the squared cancel, so we get 2x plus 1 equals, so x minus 1 times x minus 1, and then FOILing this out, we get x squared minus x, right? X squared minus x plus 1. Or x squared minus 2x plus 1. Okay. So now it looks like something we've seen before, right? It's just a quadratic equation. So I'm going to subtract the 2x from both sides. So now it's going to be, here, maybe let me cut out the middleman here. So we have 2x plus 1 equals x squared minus 2x plus 1. Okay, so I'm going to subtract 1 from both sides, so these cancel off, and 2x from both sides. So now we have 0 on the left-hand side, and we have x squared minus 4x, and that's it. Okay, so now we just have to factor this one. And this one we can factor easily because each term here has an x in it. So this is now 0 equals x times x minus 4. Okay, so now we're going to, right, we have a times b equals 0, so we set them equal to 0, each factor equal to 0 on its own, and solve. So x equals 0 is already solved. X minus 4 equals 0 can be solved by adding 4 to both sides to get x is positive 4. So our solutions before we check the original equation, x is equal to 0 and 4. So now we have to check them, right, to see if they would actually work in our original equation, to make sure they are not extraneous solutions. Okay, so let's check. Move this up here. We'll check x equals 0, and let me rewrite that original equation down here. So we got 2x plus 1 equals x. So if I plug in 0, then you get the square root of 2 times 0 plus 1 equals 0. So we're really trying to check if this is true, right? So this is the square root of 1, right, plus 1 equals 0. So there's a problem here because the square root of 1 plus 1 is just 1 plus 1. So this is really saying that 2 is equal to 0. So that's not true. So 0 is not a solution. Okay, so now we can check x equals 4. So again, it's just the square root of 2 times 4 plus 1 equals x, so equals 4. Okay, so this says that, so you get the square root of 8 plus 1 equals 4. So that's the square root of 9, which is 3, plus 1 equals 4. So this one checks out. 4 equals 4. So x equals 4 is a solution. Okay. Alright, so now let's move on to the next section. So, or the next example, sorry. So we're gonna solve an equation involving two radicals. Okay, so the example is solve, for the directions, square root of 2x minus 1 minus the square root of x minus 1 equals 1. Okay. So first thing you need to do is isolate. So, okay, let me first explain why this is different. So in the last example, we only had one radical term with a radical in it. Here we have one term with a radical in it, square root of 2x minus 1, minus another term with a radical in it. Okay? So the first thing that we should do is isolate one of these. It doesn't matter which one you do, but let's just add to isolate meaning getting it on a side by itself. So I'm going to add the square root of x minus 1 to both sides to get the square root of 2x minus 1 equal to 1 plus the square root of x minus 1. Okay, so here's what we do now. So we want to get rid of this square root here, so we're going to square both sides. So square one side, you got to square the other. So this one cancels, right? The square root and the squared cancel, but this one we have to FOIL out. So again, if I rewrite the squared here, this is just 1 plus root x minus 1 times 1 plus root x minus 1, right? These two are the same thing. That's what the definition of squared is. Okay, so if I FOIL this out, you get 1 times 1 is 1, and then you get a plus square root of x minus 1, right? 1 times square root of x minus 1. Again, another plus square root of x minus 1. And then finally we have plus x minus 1. Okay. So this can be simplified to 2x minus 1 equals 1 plus right? If we have 1 plus another one, we just put a 2 times root x minus 1 plus x minus 1. Okay, so now we've basically taken this radical expression that has 2 radicals in it, and we've reduced it to a radical expression that only has 1 radical in it. So now we just repeat the process to eliminate this one as well. So we have to isolate this radical expression. Okay. So let's, first off, we have a 1 here and a minus 1 here. So we can cross these off. And let's move this x over to the other side. So if I subtract x from both sides, subtract x, we get